Let's face it, data rates aren't going to slow down anytime soon, nor do we want them to. And frankly, our trace lengths on our PCBs are only going to get shorter. And I don't know about you, but I am not a fan of lossy PCBs. So, what can we do? We can get that signal out of the PCB and into a Twinax cable. Just fly it on over to where it needs to go. No airline ticket needed. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Matthew Burns from Samtec and I investigate the challenges of routing high-speed data over lossy PCBs. We also discuss the benefits that Samtec's FlyOver solutions bring to data center and embedded designs, and how Samtec is furthering innovation with their high-speed interconnect solutions. And before we get started, don't forget to click that link. There you can find even more information about this topic from Samtec. Hi, Matt. Thank you so much for joining me.
Hey, Amelia, it's great to be with you again on your Chalk Talk.
Excellent. All right, so we're discussing Samtec's FlyOver technology, Twinax FlyOver system for next-gen speeds today. But Matt, can you first set the stage for us? What problems is this Samtec FlyOver technology looking to help solve?
That's a great question to get started with, Amelia. And I think we've talked about this topic before. The interesting thing is that as data rates continue to get faster, flyover becomes more and more pertinent. In short, the brief answer is as data rates get faster, the trace lengths that you can have on a PCB gets shorter. We've been talking about this technology probably for about the last 7-8 years. The industry really started taking note of it when data rates go to around 56. And then now that we're dealing with 112 and 224, just about every type of system design, especially in a data center application, and now embedded, is getting data out of the PCB and into an ultra-low skew Twinax cable, which we'll talk about in a few minutes. In addition to data, as data rates get faster, one of the design approaches that engineers can take is to add a retimer or CDR. Basic signal integrity. If there's too much loss, the eye of the signal closes. And by putting a retimer or clock and data recovery, the eye of the signal opens back up. A lot of companies use that, especially for long traces on PCBs. It's a tried and true method, but it's expensive. It takes up PCB space. You have to worry about the power for those as well. Long traces, lossy elements that the traces have to go through on a PCB via multiple connectors, whatever the case may be, Amelia. So taking that signal out of the PCB, putting it into the ultra-low skew Twinax is really the solution to the challenge that we see. We can also back that up with data. If you look at traditional PCB materials like FR4, FO408, it's nearly impossible to send a 56 or 112 signal too far on the PCB without some sort of retimer. You can step up to a Megatron 6 or a Megatron 7. That may allow you to go a few inches without adding retimers. But if you take the signal out of the PCB as quickly as possible once it leaves the ASIC and put it into a micro Twinax cable, at 56 gigabit, we can get a meter or more. 112, we can get a half meter or more. So that really does answer a ton of design challenges. We also see here from the data on the far right-hand side that the loss within our Twinax cable solutions are consistent over frequency range instead of having a linear loss profile compared to traditional PCBs. So the faster the data rates, the larger the loss delta. The PCB trays have more and more loss, whereas the loss per cable is relatively flat over a large frequency range out beyond 50 gigahertz. So again, FlyOver technology answers a lot of problems. The faster data rates go, the more and more pertinent it is.
All right, so Matt, can you give me some more details about FlyOver?
Yeah, a lot of it's based on the unique capabilities that Samtec has within our high-speed Twinax cable technology. Currently, production-wise, we support anywhere from 28 gigabit up to 112 gigabit per second data rates. We've demonstrated 224 with prototype silicon, prototype IP. Our manufacturing process is what we call co-extruded. What that allows us to do is eliminate the drain wire. When you look at a number of our competitors, typically they have the differential pair using two conductors with a third wire that's within the wrapping. But because we co-extrude ours, it provides signal integrity enhancements over everything else in the industry. It gives us tight skew, tight coupling between the signal conductors. It's also smaller. We have what we call our Twinax. It's 40% smaller, moved from one generation to the next. And we're also working on a third generation of our cabling technology that we called high-speed air. From a data rate standpoint, we talked about how we can get up to 112 gigabit. Production-wise right now, we're working on 224. We should have that productized hopefully by the end of 24, early 25, depending upon how some of our development goes. In addition to the speed benefits, we can also lower power and thermal profiles across the system. You can see there in the graphic in the bottom right-hand side of the slide, the thermal image on the left-hand side is a traditional networking switch using a switching ASIC, whether that's 56, 112, 224, whatever the case may be. There's a lot of heat in the system wherever the ASIC resides. However, by getting rid of traditional PCB traces, routing the signals from the ASIC to the Twinax cable, you can move the ASIC farther back in the system, closer to the thermal management devices, and that big red spot over the ASIC is removed. So price competitiveness, thermal enhancements, lower power, overall FlyOver architecture is really redefining system architectures within the data center and also in the embedded ecosystem as well.
So, Matt, when it comes to the FlyOver QSFP connectors, would they be a good solution for these kind of designs as well?
It is, Amelia. And when you think about FlyOver, there's really three different components to it. There's the what we call the near chip connector or the ASIC adjacent connector midboard. That's one application. We have front panel solutions, which is the second, which we'll talk about here in a second with FlyOver QSFP. And then lastly, we can route the FlyOver signals from the central ASIC back to the backplane. So if you're using front panel, you need to have a front panel connector solution. So Samtec has a number of FlyOver QSFP systems that go into a traditional QSFP, QSFP DD, QSFP DD800. We're also looking at QSFP DD1600 for data center applications. The QSFP solutions can support up to 100 gigabits per lane, which can give you 800 gigabits per port. We're looking at some of the next generation technology, which will get us from 800 up to 1.6 terabyte per port. Some of the solutions, we offer double density versions. We also feature belly-to-belly mating for maximum density. Belly-to-belly refers to having the QSFP ports both on the top side of the PCB and also on the bottom side of the PCB. We also have a number of heatsink options for dissipating thermal relief within the system. Some of the listeners may ask, well, didn't you just say that FlyOver minimizes the need for heat across the system? And from the ASIC, yes, because we're removing retimers from the system. But each of the ports is going to have a active cable that's installed, whether that's optics or cable. Some of those ports have power 15 to 25 watts. And when you put 36 of those on a 19-inch rack mount solution, you still have to get rid of the heat from the electronics within the cable on the front panel. So by having a variety of heat or thermal mitigation solutions, we can help optimize thermal relief at the system level. And then with our FlyOver QSFP solutions, we also have a number of N2 products that operate at 56, 112 or future 224 when linking next to the ASIC within the system.
So, Matt, we've talked about accelerate connectors in the past here on Chalk Talk. Would they be a good fit here as well?
They are. Accelerate is really one of those families of products, whether it's a board-to-board connector or a cable connector, Amelia, that starts to bridge the gap, if you will, from data center to embedded. Accelerate is fast enough at 64 gigatransfers per second to support a PCI 6 N2 cable with something in the front panel, but it's also small and dense enough to handle the high pin count that's required for embedded applications. So for Accelerate Slim direct attached system, it's a very small PCB mount connector, 7.6 millimeter wide. We can support 8, 16, or 24 differential pairs in a two-row design. We're also working to expand that up to 72 differential pairs within a single connector. Again, we mentioned earlier when talking about FlyOver technology, one of the benefits that Samtec has over the rest of the industry is the fact that we can directly attach the conductor from the Twinax cable to the contact on the connector body. So that eliminates a transition step on the connector assembly to increase performance. So Accelerate Slim is another example where by having that direct attach, you improve the signal integrity, eliminating the transition board that's typically found in these types of solutions. Accelerate Slim also takes advantage of our ultra low skew, high performance, I-speed 34 gauge cables. The solutions can also be ruggedized with metal latching and shielding, especially for embedded applications. We also have reverse polarity pinout options that will reduce far end crosstalk. The illustration there on the lower right also shows the small size of the connector when mated. It's roughly 11 meter in height versus 15 millimeter in width. So very small, very dense, very high performance, and it's suitable both for data center and embedded applications.
So, what about Firefly? Would they also be a good solution to consider here?
Of course. And, we've talked about Firefly a number of times here on Chalk Talk. Firefly was really the first FlyOver product family that Samtec came out with probably 10, 12 years ago. The beauty of Firefly is that it supports both a copper version, which is the focus of our conversation today, but it also has an optical version. So as far as we know, it's the only solution on the market that's interchangeable between copper and optics. Because of the small footprint of the mated connector set, which is shown here on the right-hand side, you can place the high-speed connector directly next to the ASIC on the design. That could be a GPU, that could be a CPU, that could be an FPGA. Firefly is very popular FPGA-based applications, both from a copper and optical standpoint. Some of the additional features of Firefly, in addition to the fact that data is taken off the board very easily with the connector, low profile housing for space savings, designed for onboard or on-package placement. It's a low-cost solution for seamless integration from new to existing design. What do I mean by that? We tend to think of Firefly as being future-proof. If an engineer is designing a system at lower speeds, say 10 gigabit per second, which is very prevalent within the embedded space, but the engineer needs a future-proof path up to 28 or higher speeds, you can design in the Firefly footprint, add the copper Firefly in it, design, develop the system, and then you realize, okay, I can go a meter or two with copper, but I need to increase my data width and I have to go up to 100 meters with optics. I can drop in the optical Firefly, not even change the system design, and then you can go from purely electrical to an E to O conversion with our easy-to-use Firefly optical transceivers. Both on the copper side and on the optical side, we also have a wide variety of N2 options.
All right. So, Matt, before we go, can you recap your main points for me?
Love to, Amelia. As we've stated before, Samtec's FlyOver technology is redefining system architecture by enabling system designers to take high-speed signals out of the PCB and moving it into cable, whether that's copper with the FlyOver QSFP, Accelerate, and Firefly solutions we talked about, or optically with the optical Firefly version that we talked about. These are just three products of many solutions that we offer of FlyOver solutions, which are all ideally suited for routing high-speed data over lossy PCBs. Additionally, Amelia, I think we've mentioned this to you before, we back up our FlyOver solutions with our global team of technical experts. That's our FAEs, our applications engineers at the factory, our signal integrity experts, our optical experts, online design tools, world-class customer service, available for customers small and large to help design in. Something else we've also created recently, Amelia, is our brand new Samtec high-speed cable interconnect solutions guide. This provides additional details not only for FlyOver QSFP, Accelerate, and Firefly, like we talked about, but for all the product families we have that are a part of our FlyOver technology solutions. For more information, your listeners can go onto our partner site, mauser.com/Samtec, or you can reach out to our experts at sig@samtec.com.
Fantastic. Well, Matt, as always, it was a pleasure speaking with you.
It's always fun to be with you here on Chalk Talk. Thanks so much, Amelia.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Samtec. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.